Hello, and welcome to our video presentation of our ICML 2024 paper, Not Just Pretty Pictures, Towards Interventional Data Augmentation Using Text-to-Image Generators. My name is Adam Davies, and I'll begin by providing some essential background for our work. Neural image classifiers can be trained to perform very well in recognizing in-distribution samples that closely resemble the distribution of the training data. However, they often fail to generalize outside their original training distribution when tested on unseen domains. Many data augmentation techniques have been proposed to improve out-of-distribution generalization by artificially expanding models' training data with pixel space transformations that don't change image labels, such as rotating images or decolorizing them, as an ideal classifier would be invariant to these transformations. However, the design of effective augmentation pipelines can be very complex and often results in unrealistic transformations whose effect can be hard to understand. There are also many transformations, such as a change in visual style from photos to paintings, that cannot be directly implemented as pixel space transformations. In this paper, we investigate how effective generative models can be for simulating such transformations and augmenting classifiers' training datasets. In this way, the generative model's knowledge obtained through large-scale weakly supervised learning can be distilled into downstream neural classifiers to improve their out-of-distribution robustness. Theoretically, our approach is best understood in causal terms as a method for approximating interventions over environmental conditions that may be spuriously correlated with the label in the original training dataset, such as visual style or background, while keeping the label itself constant. Given a sufficiently powerful approximation, such interventional data can mitigate spurious correlations in the original training dataset, inducing the model to learn causally invariant features to perform the task instead of leveraging spurious correlations that may not hold for unseen test domains. Specifically, we study how text-to-image generators such as Stable Diffusion can be used to simulate interventional data approximating unseen domains, and test how augmenting classifiers' training data with these synthetic images can improve their robustness. In contrast to traditional pixel space augmentation techniques that must be manually and individually designed for each desired transformation, text-to-image generators enable the creation of new augmentations simply by specifying a single interventional prompt expressing the desired transformation, such as an artistic rendition of a cat to turn a photo into an image, as you see here. We experiment over three key elements of text-to-image generation to discover how they each impact the robustness of downstream classifiers. The first element is the prompting strategy used for the generative model. We begin with minimal templatic prompts describing the desired transformation that vary only by the class and domain labels, such as a painting of a dog or a photo of a cat. We also consider manually handcrafted prompts illustrating different subdomains. Finally, our third strategy prompts LLMs to generate a diverse range of sentences including both the class and domain names. Next, we experiment with several conditioning mechanisms. The first, text-to-image, conditions the generator only on text prompts. We also consider three editing techniques that are conditioned on both the image and text prompt in different ways. SD-edit adds noise to source domain images and denoises them to match the target text caption using the generator. Instruct-pix-to-pix fine-tunes the generator to edit images according to instruction-based prompts, and ControlNet generates an image matching the target text caption that maintains the edges in the original image. Finally, we use post-hoc filtering to remove low-quality generated images that may or may not match the target domain or class label by filtering out those with a low clip similarity to the corresponding minimal prompt, and experiment with different similarity thresholds used for filtering.
We first test our T2I-based data augmentation in the single-domain generalization setting. So the idea is we want to have a visual model trained with data from a single domain to generalize well to unseen domain at test time. So to perform this interventional data augmentation, we use text-to-image generators to produce a set of new images by perturbing the domain-specific description of the original training images. For example, for an elephant image from a painting domain, we use the prompts such as cartoon of an elephant, a sketch of an elephant, to edit the image such that the new image will be used also for training and help the model to generalize to the target new test domain of cartoon, sketch, and so on. As shown here, our SDG experiment quantitatively shows the advantages of using T2I-based data augmentation. In particular, over 4 different datasets from different types of image domains, T2I-based IDA outperforms all traditional data augmentation methods. This is a significant result because it shows that even the most naive choice of generation parameter and the mechanism can lead to superior performance. In the meanwhile, by using different prompting strategy, we observe that prompting with handcrafted or LLM augmented template is better than minimal templates. This indicates the effectiveness of injecting human prior and diversifying the data. Moreover, we find the conditional mechanism used for generation can also make a difference. However, we observe that such effect is more dataset dependent. For example, retrieval is effective in packed and office home dataset, but not that much in NiCO++ and the domain net. In the contrary, control net is very good for NiCO, but not for others. Overall, we observe that the T2I image editing performs the most stable performance. However, there is no universal best option. Furthermore, another dimension we investigate is the post-hoc filtering, where the generated images are first filtered before added to the augmented training set according to the clip similarity between the text prompt and the generated content. This is intended to increase the quality of synthetic images. However, we find even without filtering, the synthetic images are already good enough, serving as good IDA examples. We further test our T2I-based data augmentation in reducing reliance on spurious features, RRSF. The idea is we want to train a robust visual model using a set of biased training images with spurious correlation presented between non-causal variable and class label. For example, the camel usually coexists with a desert background, which makes the visual model lean towards classifying any animals in the desert background as camel. We use a T2I image generative model to synthesize the confounding images to break such spurious correlation by using prompts such as a camel on the snow, such that by training with these augmented images, the classifier can learn a more robust and causal features. Again, we quantitatively show that all T2I-based IDA method outperform the traditional data augmentation method in terms of RRSF. Here, we observe that conditional mechanism again plays a significant role, where T2I is, in general, the most robust solution.
In conclusion, we find text-to-image generators to enable flexible, simple, and powerful interventional data augmentation mechanisms. These editing and synthesis techniques can effectively be used to augment the training data to improve the robustness of classifiers trained on a mixture of real and synthetic data. We conclude that the most important factor to produce effective augmentations is conditioning, followed by prompting. Filtering has almost no impact. While we find there's no silver bullet that allows to optimally address all application scenarios, the simplest configuration using text-to-image and minimal prompts is sufficient to significantly improve the robustness of the classifiers.